Good morning, student. In the last classes, we are seeing the chapters limit, under which we are solving the questions of all the types which we have already studied. Now today we will see some other questions. Okay, and we will practice it. Let's see. First question is limit x tends to a x plus 2 to the whole power 5 by 3 minus a plus 2 to the whole power 5 by 3 by x minus a. Okay, student. So this is our question. So first of all, student, we will make this. We will write that this is our x plus 2 to the power 5 by 3 and minus a plus 2 to the power 5 by 3 by x plus 2 minus a plus 2. We can write this. We are adding plus 2 and subtracting 2, student, and taking negative outside. Okay, student. So we can write this. Now, student, we will suppose that let this x plus 2 is equal to y. Okay, and this a plus 2 is equal to our b. Okay, student. Then we can write, student, limit. This is our x tends to a, student. So we are adding here plus 2 and plus 2 here, plus both side. So it will change in b, y tends to b. Okay, and this is, we can write y to the power 5 by 3 minus b to the power 5 by 3 and divided by y minus b. Okay, student. And this is our standard result. You know, our standard result is limit x tends to a, x to the power n minus a to the power n by x minus a, which is equal to n a to the power n minus 1. Okay, student. So we will replace this. So here our n is 5 by 3 and a is b. Okay. So n a to the power n minus 1, student. So we can write this. Okay. So 5 by 3, our b is what? A plus 2 we can write to the power 2 by 3. Okay, student. So this will be our answer. I hope you understand. Let's see once again, student, what we have done in this question. This is limit x tends to a, x plus 2 to the power 5 by 3 minus a plus 2 to the power 5 by 3 divided by x minus a. So first of all, we have made the denominator also like numerator. Okay, so we have added here plus 2 and subtracted here minus 2. Okay, and taking this is our y and this is our b. Okay, student. So limit y tends to b, we write y to the power 5 by 3 minus b to the power 5 by 3 divided by y minus b, student. And this is, you know, our standard result. Limit x tends to a, x to the power n minus a to the power n by x minus a. So this we can replace n a to the power n minus 1. At the place of n is 5 by 3, b to the power 5 by 3 minus 1. Okay, student. So 5 by 3 and our b is a plus 2. So we can write here a plus 2 and to the whole power 2 by 3. So this will be our required result. I hope you understand, students. Now we move to next question. Let's see. limit n tends to infinite factorial n plus 2 plus factorial n plus 1 divided by factorial n plus 2 minus factorial n plus 1. Okay, student. Now this is limit n tends to infinite. So student, we are seeing that every terms which is written in numerator and denominator is under the factorial. So we will use the concept of factorial, and you know our factorial n can be written as n factorial n minus 1. Okay. So student, by the use of this concept we will use here, our here is n plus 2. So when we will take n plus 2 outside, our inside factorial will be less than 1. Okay student, we can write n plus 1 factorial plus again, and here n plus 1 is as it is. The same work we will apply in our denominator. We get n plus 2 outside and n plus 1 inside. Okay student, minus this is our n plus 1. Okay student, now limit n tends to infinite student. Our n plus 1, we are seeing that student n plus 1 is here, n plus 1 is here with the factorial. So we will take outside n plus 1 and inside is n plus 2 plus 1 and divided by again n plus 1 is here. So we will write n plus 2 minus 1. So n plus 1 and n plus 1 will be cancelled in numerator and denominator both. So limit n tends to infinite. Here we write n plus 3 by n plus 1. Okay student. Now student, we will take, here is n tends to infinite. So you know the concept of infinite, how we solve it. We take the maximum power of the variable in numerator and denominator outside, then we put the limit. So here is n, so we take n outside, limit n tends to infinite, n outside 1 plus 3 by n and divided by n 1 plus 1 by n. Okay student, so n is n will cancel in numerator and denominator, and the remaining term is this. Now we put our limit, we get what? 1 plus 3 by infinite by 1 plus 1 by infinite. Okay student, so we are seeing that this term and this term will be 0 and we get 1 by 1 which is 1, and it will be our required result. I hope you understand students. In this question just we are using the concept of our factorial notation, and you know our factorial notation can be expressed like this. Our factorial n is equal to n factorial n minus 1. Okay, and this is, suppose that we are taking an example. If here is factorial 6, then we can write 6 and factorial 5. Okay, so here we are applying, here is n plus 2. So when we are writing n plus 2 outside, our factorial notation, factorial term will be less than 1. So it will be changing n plus 1 factorial, and this is same as the same procedure we apply in the denominator. We write n plus 2 outside and n plus 1 factorial, and this is minus factorial n plus 1. Okay student, now we are seeing that n plus 1 factorial n plus 1 is in numerator and denominator both. So we are taking outside factorial n plus 1 in numerator and denominator, getting what? N plus 2 plus 1 and n plus 2 minus 1, and this is, we are seeing that factorial n plus 1 factorial n plus 1 is cancelled in numerator and denominator. The remaining term is what? N plus 3 by n plus 1. Okay student, now for solving the limit, we will take n outside in numerator and denominator also, and we are seeing that n and n will cancel to each other. Now the remaining term is 1 plus 3 by n divided by 1 plus 1 by n. Here we substitute our limit. Okay student, at the place of n we will write infinite. We get this term is 0, this term is 0. Okay, so our 1 by 1 which is 1. I hope you understand, students. Now we move to next question. Let's see. Our next question is, student, limit x tends to infinite, x plus 1 to the power infinite plus x plus 2 to the power here is x plus 1 to the power 10, x plus 2 to the power 10 plus dot 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 x plus 100 to the power 10 and divided by x to the power 10 plus 10 to the power 10. Okay, student. So this is our question and we have to find the solution of this limit. Okay, students. So limit x tends to infinite. We are seeing that here is limit is infinite, so we will take the maximum power of the variable outside in numerator and denominator, students. So first we will take x to the power 10 outside. This is 1 by x to the power 10 and here x to the power 10. So 1 plus 2 by x to the power 10 plus dot 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 x to the power 10 once again. So 1 plus 100 by x divided by to the whole power 10 and in denominator we are taking x to the power 10. So 1 plus 10 to the power 10 by x to the power 10. Okay, student. Now limit x tends to infinite. We are seeing that x to the power 10, x to the power 10 dot 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 x to the power 10. So we take x to the power 10 outside. We get 1 plus 1 by x to the power 10. Okay, student. Now here 1 plus 2 by x to the power 10 plus dot 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 1 plus 100 by x to the power 10 and divided by x to the power 10, we get 1 plus 10 to the power 10 by x to the power 10. Okay, student. So we are seeing that this x to the power 10, x to the power 10 is cancelled. Now we will put the limit and we get 1 plus 0 to the power 10, 1 plus 0 to the power 10 plus dot 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 1 plus 0 to the power 10, okay, and divided by 1 plus 0 to the power to power 10, and here we are writing this is 100 times because this is 1 plus 100 by x and we are starting from 1 to dot 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 100. Okay, student. So this is 1 plus 1 plus 1 dot 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 plus 1. How many times, student? 100 times we can write. Okay, and this is divided by 1. So it will be, we can write 1 into 100 which is 100. So it will be our required result. I hope you understand, students. Let's see once again what we have done in this question. This is limit x tends to infinite. We have taken the power of x outside, here x to the power 10. So it will change in 1 plus 1 by x to the power 10. Again here taking x to the power 10. The power 10 is because of the power 10 this. Okay. So 1 plus 2 by x to the power 10 plus dot 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 plus x to the power 10 outside. 1 plus 100 by x to the power 10 and taking x to the power 10, we are getting 1 plus 10 to the power 10 by x to the power 10. Okay, Now x to the power 10 outside, 1 plus 1 by x to the power 10. Here 1 plus 2 by x to the power 10 plus dot 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 1 plus 100 by x to the power 10 by x to the power 10, 1 plus 10 by x to the power 10. Here student, we are seeing that x to the power 10 and x to the power 10 cancel. What we are getting, now we are putting the limit. So here we are substituting infinite, infinite, infinite. This is 100 times 1 plus 2 plus dot 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 100 times. Okay student, so this is cancel from numerator and denominator. Okay, now 1 plus this we can write 0 0 0, and this is student 100 times, because this is 1 by x, 2 by x, dot 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 100 by x. So 100 times is this, so we can write 1 plus 1 plus 1 dot 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 100 times 1. Okay, so this 100 times 1 can be written as 1 into 100, and 100 will be our required result. I hope you understand, students. Now we take another question and solve it. Our next question is, student, fx is equal to ax plus b by x plus 1, limit x tends to 0, fx is equal to 2, limit x tends to infinite, fx is equal to 1, fx is equal to 1, then prove that f minus 2 is equal to 0. Okay student, so these are the information about this question, in which we have to given fx is ax plus b by x plus 1, and limit x tends to 0, fx is 2, limit x tends to infinite, fx is 1. Then we have to show that f minus 2 is equal to 0. Okay student, now we see the solution of this question. So first of all, student, we will take first limit, which is limit x tends to 0, fx is 2. Okay student, now limit x tends to 0, our fx is given to us ax plus b by x plus 1, which is equal to 2. Okay, now student, we put the limit here direct, so we get b, and here is 0 by 0 plus 1, which is 2. So from here we are getting our b is 2, student. Now our second limit is limit x tends to infinite, fx is equal to 1. So limit x tends to infinite, fx is ax plus b by x plus 1, which is equal to 1. Okay student, so for solving this, student, we will write our limit is x tends to infinite, so we will take x outside from numerator and denominator, and we get 1 plus 1 by x, which is equal to 1, and this is, we are putting our limit, which is infinite. We get what, student? So student, we are getting from here, this term will be 0, and here 1 plus 0, so we get a is equal to 1. So we are getting our a is 1 and b is 2. Now we have to find out f minus 2. Okay student, so fx is ax plus b, this is our fx. Now we are putting the value of a and b. So a is 1, so 1 into x. b is 2 by x plus 1. Okay student, so this is our fx. Now student, we have to find the value of f minus 2. So put x is minus 2, so we write f minus 2 is minus 2 plus 2 by minus 2 plus 1, which is 0 by minus 1, which is equal to 0. So in this way we have proved that our f minus 2 is equal to 0. I hope you understand students. First of all, we have to given this fx, limit x tends to 0, fx is 2, limit x tends to infinite, fx is 1, and then we have to prove that f minus 2 is equal to 0. Okay student, and so first of all we are taking this limit, which is limit x tends to 0, fx is 2. Now we are putting the value of fx, which is ax plus b by x plus 1, which is 2, and we are substituting the value of limit 0 here. So we are getting 0 term 0, and this is b is equal to 2 from here we are getting. And now taking the second limit, limit x tends to infinite, fx is 1, limit x tends to infinite, ax plus b by x plus 1 is 1. So student, limit x tends to infinite, x outside from numerator, x outside from denominator. So x is x and x will cancel. So the remaining term is what? A plus b by x by 1 plus 1 by x student. Okay. So we will put our limit here. We get a plus b by infinite, 1 plus 1 by infinite. Now you know that this term will be 0, this term will be 0. So we get from here a is equal to 1. Okay student. Now we will find our fx is ax plus b by x plus 1. So fx is equal to ax plus b by x plus 1. Now student, here we will substitute the value of a and b. Our a is 1 and b is 2. So we get x plus 2 by x plus 1. Now we have to prove that f minus 2 is equal to 0 student. So fx is this. Now we put at the place of x is minus 2. Okay. So f minus 2 will be what? Minus 2 plus 2 by minus 2 plus 1. And here this is 0 by minus 1. And in this way we can prove that our f minus 2 is what? 0. I hope you understand students. Now we take another question and solve it. Let's see. Our next question is limit x tends to 0 sin 2x plus sin 3x by 2x plus sin 3x. Okay student. So this is our next question and we have to find the limit of this question. Okay. So limit x tends to 0. First of all, we will divide the numerator and denominator by x. So we get sin 2x by x, sin 3x by x, and by 2x by x plus sin 3x by x, dividing numerator and denominator by x. Okay. So student, what we are getting from here, now we will make this part sine 2x by 2 into x and into 2. Now separating the limit with numerator separately and denominator separately. Okay, so we write limit here also, x tends to 0 sine 3x by x. Okay student, now we divide with 3 and multiply with 3. Okay, in the denominator this term will be cancelled, so this is 2. So limit x tends to 0 2 plus limit x tends to 0, this is sine 3x by x. Here multiply with 3 and divide with 3. Okay student, now we are seeing that our this part is equal to 1. So this is 1 into 2 plus this part is also equal to 1. So this is, and this part is constant, so this is 2, and here this part is 1, so we can write 1 into 3. Okay student, so we are seeing that this is 2 plus 3 by 2 plus 3, 5 by 5, which is equal to 1. I hope you understand students. Let's see once again, limit x tends to 0 sine 2x plus sine 3x by 2x plus sine 3x, and limit x tends to 0 sine 2x, we are dividing in numerator and denominator both by x. So we are getting this is x, this x, this x and this x. Okay, and now we are taking the limit separately in numerator and denominator. We get x tends to 0 sine 2x by x, and here multiply with 2 and divide with 2. Again this term is there. Now take limit with this term. So limit x tends to 0 sine 3x by x, multiply with 3 and divide with 3. Okay student, now here is this x and x will reduce and we get just 2. Okay, now take limit with this term. So limit x tends to 0, this is 3x by x. Okay, so multiply with 3 and divide with 3. Now this part is 1, this part is 1, and this part is 1, and this is 1 into 2, 1 into 3, 2 and 3. So our result will be what? 1. Okay, now we take another question students. Our next question is, next question is, limit x tends to pi by 2 sec x minus tan x. Okay student, so we will write limit x tends to pi by 2, this is, we can write 1 by cos x sin x by cos x, and this is limit x tends to pi by 2, taking cos x LCM we write 1 minus sin x. Okay student, now if we are changing this h tends to 0, so at the place of x we can write 1 minus sin pi by 2 plus h by cos pi by 2 plus h. Okay student, so limit h tends to 0. Here 1 minus sin 90 plus theta is cos theta, so we write cos h, and cos 90 plus theta is minus sin h, so we write minus limit h tends to 0, and this 1 minus cos h we can write student 2 sin square h by 2, and this sin h we can break this 2 sin h by 2 cos h by 2. This 2 and 2 will reduce from here, and this part is cancelled, and we are getting limit h tends to 0, and this is tan h by 2. Now limit, now student we are putting the value of limit, we get tan 0, and which is equal to 0. Okay student, so let's see once again. Limit x tends to pi by 2, this we can write 1 by cos x, sin x by cos x, we write 1 minus sin x by cos x after taking LCM. Now here we are taking that x minus pi by 2 is h, so x is pi by 2 plus h. Okay, so h is tends to 0 student, we write sin x pi by 2 plus h, here cos pi by 2 plus h, sin plus 90 plus theta is cos theta, and cos 90 plus theta is minus sin theta, and this part we can write 2 sin square h by 2 and minus limit h tends to 0, and this part 2 sin h by 2 cos h by 2, this 2 and 2 will cancel, sin h by 2 will cancel, the remaining term is tan h by 2, we are getting tan 0 which is equal to 0. I hope you understand friends, so thank you so much.